Graphing with the tracker software. In this experiment, we are going to learn how to make a plot in our lab activities by using tracker software. We will plot a lot of graphs through this semester, so plotting graph and understanding the parameters in the graphs is important. What's the tracker? The tracker video analysis and modeling tool allows us to model and analyze the motion of the object in videos. But in this lesson, we'll just see making basic plots by using given data. For this purpose, of course, you need the tracker software. If you don't have, you can download it freely from its homepage using this link. Since the tracker requires Java, be sure that Java is installed on your computer. You can use this link to install Java. If you need a quick guide to graphing with the tracker, I suggest you to watch this video. Before showing how to make plots based on given data, let's take a look at the data tables. We see that the data tables include position data of moving object at various times. There are 6 measurements for each set. And although there is no problem with the clock, there is some uncertainty in position measurements. When scientists make a measurement, they generally assume that some exact or true value exists. This value, based on how they define what's being measured, scientists reporting their results usually specify a range of values that they expect this true value to fall within. This is the most common way to show the range of values is, where 9.6 is referred to best estimate and 0.5 uncertainty. The position measurement of 9.6 plus minus 0.5 means that the experimenter is confident that the actual value for the position being measured lies between 9.1 centimeters and 10.1 centimeters. The uncertainty is the experimenter's best estimate of how far an experimental quantity might be from the true value. If we look at the sets, we see that the uncertainty values in the sets are different. There is no doubt that these differences will affect our experimental results, but we will comment on this later. So let's put the uncertainty aside for it now and examine the first set. The table contains the position of the object at regular intervals of time. In this case, once each 1 second. Notice that the object displays almost 10 centimeters between each seconds. When an object displays an equal distance every second, then the object is said to be moving with constant velocity. If an object is moving with constant velocity, the graph of distance versus time shows the same change in position over each interval of time. Therefore, the motion of an object with constant velocity is represented by a straight line. The slope of the graph represents the velocity of the object. To see why, consider the slope of the position versus time graph. The slope of the position graph is rise over run, and rise is x2 minus x1, and run is t2 minus t1. This expression for slope is the same as the definition of velocity. Velocity is the rate of displacement with time. So the slope of a position graph has to equal to velocity. And the line can be represented algebraically as where x0 is the displacement when t equals 0. Now that we remember the position time graph, we are ready to make a plot of data tables using the tracker. For this, I will choose the first data set. Although there are 6 data, I'll only use 5 data to teach, so the results will be different from what you will get. Let's open the tracker. On the screen that opens after running the tracker, Data Tool Analyze is selected from the View tab. Then New tab is selected from the File section. The opening page is the page that allows us to analyze the data. Firstly, define the axis. For this, use New Column button. You can change the axis by clicking on it. In physics, time is usually the independent variable. Other quantities, such as displacements, are said to depend upon it. A graph of position versus time, therefore, would have position on the vertical axis and time on the horizontal axis. Now we can enter the data. To switch the next row, press Enter on the keyboard. As you see, after entering the data, the position and time data are simultaneously recorded on the graph. After entering the data, to plot the graph, select Curve Fits from Analyze tab. And since we know that the data fits motion with constant velocity, and motion with constant velocity is represented by a straight line, line should be chosen as fit name. The best straight line is fitted by the tracker. Since the slope of this line is equal to constant velocity, the parameter A, which is the slope of this line, is equal to the constant velocity. The parameter A is equal to 9.870 times 10 to 0 centimeters per second, namely 9.870 centimeters per second. The parameter B, which corresponds to the position at time t equals 0, is equal to 2.500 times 10 to the minus 1 centimeter. Root mean squared deviation value is the uncertainty in position measurement obtained from the best fit curve of the plot, fitted by this equation. Due to the uncertainty in position measurement, there would be an uncertainty in velocity calculation. This uncertainty can be observed keeping mouse on the parameter A. In order to see it, auto-fit must be selected. The uncertainty in velocity calculation is also calculated by using this formula, which is obtained statistically. This sign is referred to the summation, and V slope is the slope of the best fit curve of the plot. It's the parameter A, which was found as 9.870 centimeters per second. TA is the average of time. It is equal to the summation of time measurements divided by the count of time measurements is equal to 3 seconds. Ti and Xi are each time and position measurements in the data tables. By putting explicitly all the values in here, we can calculate the delta V. Let me put the values in the equation. T1 times V slope minus X1 squared plus T2 times V slope minus X2 squared plus T3 times V slope minus x3 squared plus t4 minus x4 squared plus t5 times v slope minus x5 squared divided by t1 minus t average squared t2 minus t average squared plus t3 minus t average squared plus t4 minus t average squared plus t5 minus t average squared in square root. If we calculate, it's going to be to prevent repeating figures that aren't significant, numbers must be rounded and delta V value should be rounded according to V value by taking into consideration the digits after the decimal point. It has 3 digits after the decimal point, so delta V must have 3 digits after the decimal point. This value is the uncertainty in velocity calculation obtained from the best fitted line. It should be calculated for each set and compared with each other. V slope value is equal to this value. While preparing report, use the report template, which you can download it using this link. Let me open it. Don't forget to write the group members' names and numbers. You should write the abstract section in your own sentences. There is guidance on how to write here. You can skip the materials and procedure sections, only reading. There is important reminding at the beginning of the data and plots section, which should be read carefully. You should answer all the questions. Put the plot here with corresponding table. Let me put and fill in the table. You can delete it. Parameter B. RMS deviation is the uncertainty of the position measurement. Do the same things to other two sets. You must calculate slope uncertainties clearly as I did. You should calculate it for each plot. And in the discussion part, there is guidelines as in the abstract to utilize and questions to answer. Don't forget compare all the uncertainty calculations and comment on the differences. To summarize finally, make sure that your report contains 3 plots with the corresponding tables. Each plot must contain fitting parameters and error analysis. You must calculate slope uncertainties clearly for each plot and report them with the corresponding slope values. When writing physical quantities, don't forget to write their units. You should compare all the uncertainty calculations and comment on the differences in the discussion part.